For example, number 6, we're asked to curve sketch this guy right here. So the first thing we do is we look for symmetry. Now it doesn't have any because this is not an even or an odd function. You can go ahead and test for that. Also, we know that there are no asymptotes. This guy is a polynomial, so that's not an issue. This is a continuous function. Then we can start taking a look at the end behavior of the function. We know, again, it'll head up and to the right, down and to the left. And we can start looking at the derivative. So that's going to be 6x squared minus 8. Now the question is when is the derivative equal to 0? Well, that's when 6x squared is equal to 8, which means x squared has to be equal to 8 over 6, which is 4 over 3. And of course, that implies that x is equal to plus or minus 2 over the square root of 3. Or, most people like to write this as 2 square roots of 3 over 3. Okay? Now, that gives us two possible critical values. So that tells us that it's possible when x is 2 divided by the square root of 3 and when x is negative 2 divided by the square root of 3, we have critical points. Moreover, what we should check is see what is f double prime of x, and we know that that is just 12x. And this right here is equal to 0. So for an inflection point, it's equal to 0 when x is 0. To verify that that actually is an inflection point, we take a look at the third derivative and we just get 12. That's not 0, so this guy is an inflection point. Now to check these guys up here, we just verify that this guy is not 0 at either of these two, and that's true, it's not. So we know that we have mins and maxes. Now the question is, which one do we have? Well, when we use the negative version of this and we plug it into the second derivative, we come up with a negative value, which means that we must be at a maximum because it is concave down. And then when we plug in this, we get a positive value, okay, which means that it is concave up. Now the question is, where do these guys fall? Okay, so we know that this guy, if I write down 2 square roots of 3 over 3, this guy is a minimum. And negative 2 square roots of 3 over 3, we know this guy is a max. We know that the point 0, 1 is a point of inflection. Okay. Now, how do we get these other values out? Well, if we take these guys and plug them into here, we can see what we get out. Okay. But let me just save you some of the work here. This guy comes out to be about right around 7.2. Okay, so we'll say just right around 7. And this guy, when we plug in 2, it comes out to be right around like -5, just a little bit more than -5. So there's my 2 points. We know that this guy must look like this. This guy must look like this. We also know that there is an inflection point here at +1. Okay, so that's where we change concavity. Like that. So it looks like we're concave down over this interval, concave up over this interval right here. This guy we know has got to head down. This guy we know has got to head up because of the end behavior of the function using the limits as we go out to the sides. Now, the only other thing that we could really look for are the x and y intercepts. We already have the y-intercept. The x-intercept's not that important. We know it's somewhere over here positive. We just don't know exactly where it's at. Okay. And so this gives us our general sketch of our curve.